Last problem, number 16, a tether ball and a rope. Angle between the rope and the pole, no vertical acceleration. What's the ball's speed? Free body diagram, kinetic diagram required. So let's go ahead and draw. This is a tether ball. Here's the pole. The angle given is that angle in there. Okay, so we're going to isolate the ball hanging on the rope here. So there's the ball. There's the ball. The only thing that's supporting the ball is the tension in the rope. Come on, colors, switch. Okay, so I'm going to draw the tension in the rope. That rope is 36 degrees. Okay. The other force on the ball is the weight. Okay, the pole is over here, so the ball's rotating, and there's going to be a normal or centripetal acceleration component there, and it said there was no vertical acceleration, so that is the only component here. So that's what we're looking for. That's all we're looking for. Let's go ahead and, just to make it a little simpler, we'll use x to the left and y up. Okay, that's arbitrary. And we'll write our x equation here. So in the x direction, which is to the left, and we'll label this as the tension in the rope. Okay, so the tension in the rope times the sine of 36 is equal to the mass of the ball times the normal acceleration of the ball. So there's one equation. Lots of unknowns: tension and normal acceleration. In the y direction, we have the tension in the rope times the cosine of 36 minus the weight is equal to 0. Alright, so from this equation, we can solve for tension is equal to weight divided by cosine of 36. Okay, so the weight is 0.5 pounds, so tension is equal to 0.5 pounds divided by cosine 36 is equal to 0.5 divided by cosine 36, 0.618 pounds. Alright, so we can come back up to this equation now. We know the tension, we know the mass, we can find a normal acceleration. A sub n is equal to 0.618 sine 36 divided by the mass, which is 0.5 over 32.2. Okay, so that just comes from that equation right there. Okay, that's going to give us a normal acceleration. I'll go ahead and get a number for that. Times sine 36 divided by 0.5 divided by 32.2 quantity. Looks like 23.39. Okay, if I look at units on that, it's normal acceleration, so it should be feet per second squared. Again, we'll sort of write things out here. This is in pounds, this is in pounds, and this is in feet per second squared. So the feet per second squared come to the top when you divide by a division, so that would be feet per second squared. Almost there. We want to find the speed. We also know that the speed, the normal acceleration is v squared over r. And we know that it's an 8-foot rope. So if I come up here and draw my rope, draw 36 degrees, this is r. So r is equal to the hypotenuse times the sine, 36. Go ahead and get a number for that. 8 sine 36, 4.7. Okay, so v is the square root of a sub n times r is equal to the square root of 23.39 times 4.7. Times 23.39, square root of that number. 10.48, about 10.5. Again, units. This is, oops, come on, colors. Feet per second squared, and that's feet, and we're taking the square root of it. So this is going to be 10.5 feet per second. Pretty long problem, but key components, free body diagram. Let's break it into two equations, solve for one. Get the normal acceleration. Remember the definition of normal acceleration to solve for v.